Hello and welcome to time series forecasting. In this video I'm going to continue talking about selecting predictors, and I'm going to use the concept of adjusted R squared in relation to the concept of R squared that I defined earlier, where we saw that R squared shows the variation in y as explained by all the explanatory variables. Now the major problem with R squared was that any variable on the right hand side, no matter that variable is related to our variable y or not, tends to increase R squared. So this is very problematic because sometimes we may include a very unrelated variable on the right hand side of the equation, and our R squared may be telling us that our model is improved by the inclusion of that variable. So essentially this is what we don't want. We want to select the best predictors of y among a list of x variables. So what we can do is we can use the concept of adjusted R squared, which takes care of the problem of degrees of freedom. What we do while calculating adjusted R squared, represented by this R squared bar, is we adjust the value of our R squared, and this is the same R squared which is reported with any statistical program. So what we do here is we adjust the value of R squared to take care of the degrees of freedom. That is, as soon as we include a variable in the model, adjusted R squared will penalize the model by the inclusion of that variable, and the value of R squared adjusted will go up only if that variable is actually having a real impact on yt, that is, if that variable is a good predictor of yt. Otherwise the value of adjusted R squared will go down. Now this is different from the value of R squared because the value of R squared always increase if we include an extra variable in the model, but the value of adjusted R squared will penalize the model if we have say two models, our model 1 and model 2, and our model 1 contains only one variable and our model 2 contains two variables. We will choose a model based on whatever model is giving us a maximum R squared value. So we'll choose between these two models and select the model which has a higher adjusted R squared if we are using the criterion of adjusted R squared to select between these two models. So if model 1 will give us a maximum adjusted R squared, it means x1 is a good predictor of yt alone. On the other hand, if adjusted R squared is higher for the second model, it will show us that in addition to x1, x2 is also adding to the predictability of yt, and it's improving the accuracy of our model. Hence we should be including x2 in the model as well. So this is the first criterion that we can use to select our model. Essentially this is based on the concept of R squared, which shows how much variation all these x variables on the right side are explaining in this yt or dependent variable. In this case, we want a model with the maximum value of adjusted R squared. Alright, I'll see you in the next video to talk about the second criterion that we can use to choose our predictors.